So, to motivate the discussion of expected value, I have a probability distribution table for a random variable x, which represents the rounded magnitude of recorded earthquakes between the years of 2000 and 2012 in North America. So this is based on historical data, which you can find on the U.S. Geologic Services website. And we have that the rounded magnitudes range between 5 and 8. So 6 means if you round up or down, you have the magnitude is approximately 6.0. And we have the probabilities of these coming from the relative frequencies of these earthquakes. Now, this is based on historical data, so we can find, sample data, these x sub 1s through x sub n, that are the magnitudes themselves. And when you arrange them into a relative frequency distribution, then you get something that approximately looks like this. But suppose that we're using this probability distribution that we assume is representative of the population of all magnitudes of all earthquakes anywhere, okay? And our task, our goal, is to find the population mean, mu, okay? If we had the raw data, right, so using our previous knowledge of statistics, so one approach would be to find the sum of all the data values ever and divide that by the number of all earthquakes ever, right? If we had the population data set. And we could break that up into, if we arrange them, sorted them, then, some number of them are 5, some number of them are 6, all the way down the line until you get to the very last one, which is an 8, we assume, divided by the total number of these values, right? But if we wanted to write this slightly more compactly, right, since we're repeating the same data value over and over again, then maybe it makes more sense to simplify how we write each distinct kind of value as multiply the 5, the value itself, times the number of these 5s, plus 6 times the number of 6s, ... all the way down the line for all the unique kinds of values. And divide that by capital N. If we can even manipulate this even further, split up this fraction, we can kind of write mu, the population mean, to be 5 times the proportion of 5s, so the relative likelihood of 5s, plus 6 times the relative proportion of 6s, and so on for each distinct possible outcome. So why are we doing this? Because this is actually how we're going to define the expected value of a probability distribution. So given a random variable, x, which is discrete for now, we'll have expected value for continuous random variables as well later on, we define the expected value mu as mu being the sum over all possible outcomes, all measurable outcomes, of the outcome itself times the probability of that outcome. So what we're actually doing here is we're measuring center of a probability distribution and we can also call mu the expectation. Mu is the expectation. And we can also call it the mean of the distribution. So these are all interchangeable, but this is how we calculate it, and this is what it means. And roughly we mean then, if we repeat so from a frequentist approach, so if we repeat this experiment infinitely many times, and we obtain the mean of the outcomes, and this is kind of what we meant earlier when we said we're trying to find the population mean, then this is the expected value. So in the long run, what is the mean of the values that we are interested in, right? So in other words, we take this expression here and we're writing it now where instead of relative proportion, we're thinking probability. So in terms of that example, the expected value, we can think of it as 5 times the probability of the random variable taking on that value, plus 6 times the probability of x taking on the value of 6, and so on until we've exhausted all the distinct possible outcomes for that random variable. Just be sure that you know from context that we mean where we mean the mean mu of a population data set or the expected value of a random variable. So sometimes they're equivalent in that frequentist classical sense, just as we discussed here, and sometimes they're different. So just make sure you know which interpretation is more appropriate for what we're working with. Okay? And so in a future video, then we'll talk about some specific examples and how we can connect that to thinking about lottery and how health insurance works.